This is the key to the de Moivre's theorem homework worksheet, and the first question asks you to find the 8th roots of 1. In other words, all the numbers that you multiply times themselves 8 times to get 1, and it turns out there are 8 of them. And you probably can figure out one of them is 1, one of them is -1. You might even be able to figure out I and negative I, but this is how you find all of them. So you start by putting 1 into polar form, and since 1 is just to the right on the polar axis, 1 unit, that would be 0 degrees. So 1 cosine 0 plus I sine of 0. The first root is found by taking 1 to the 1/8 and 1/8 times 0. So you just end up with cosine 0 plus I sine of 0. So that's just saying that one of the 8, that's the same numbers you have basically to start with. So one of the 8th roots of 1 is 1. Then the second thing you do is you add 2 pi to the original angle and take 1/8 of that. And so 1/8 of 2 pi is 1/4, or pi over 4, I'm sorry. So you have cosine pi over 4 plus I sine pi over 4. And of course 1 to the 1/8 is going to always be 1. Then you add another 2 pi. So you have 1/8 times 4 pi, which gives you pi over 2. Then you have 1/8 times 6 pi, which gives you 3 pi over 4. And you keep doing that. 1/8 times 8 pi, which gives you pi. And these are all of the different roots. Notice they are all pi over 4 units apart. If you plot them, they look like little spokes all going around the 1/4 all the way around. Now, the ones that are on the axes are 1, I, -1, and negative I. So the first root, the third root, the fifth root, and the 7th root are 1, I, -1, and negative I. The other ones are all at a 45-degree angle. So if I drew a right triangle to represent those particular values, I'll get a 1, 1, square root of 2, 45-degree special triangle. And so if I wanted to write these numbers in rectangular form, the 2nd root, the 4th root, the 6th root, and the 8th root all have 1 over the square root of 2 for sine and cosine, or in rationalized form, that's square root of 2 over 2. So I've written it that way. So the first one would be square root of 2 over 2 plus square root of 2 over 2i. In the second quadrant, the cosine would be negative and the sine would be positive. So our first term, which is cosine theta, would be negative. In the third quadrant, both of the cosine and the sine are negative, and then the fourth quadrant, just the sine part, would be negative. So those are all of our rectangular forms. If you raise those to the 8th power on the calculator, you should get 1. Now if we scroll down a bit, looking at problem number 2. Problem number 2 is -16i. -16i is going straight down on a polar axis, and so it would have an angle of 3 pi over 2. And I didn't actually draw a picture of that. Maybe I can kind of quickly make a little sketch here. I think I can do this. So basically we're looking at this number here, 3 pi over 2, and a radius of 16. So I'll kind of get rid of that. Oh, hate it when it does that. All right. Applying de Moivre's theorem, we'd take 16 to the 1/2. We're doing square roots, and then 1/2 times 3 pi over 2. So you'd get 4 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Then you add pi over 2, or 2 pi, to the original angle, 3 pi over 2, and that ends up being 7 pi over, I should say 7 pi over 2, not 7 pi over, oh, it is 7 pi over 2, but then when you multiply it by 1/2, you get 7 pi over 4. So those are the 2 roots, those two. Those are 45, 45, 90 triangles also, so that's how you get them into rectangular form, similar to number 1. And when you multiply them both by 4, distribute the 4, then you get -2 square root of 2 plus 2 square root of 2i, and so forth. So I think that's a little fairly self-explanatory there, based on what we just did with number 1. And then raising them to the 2nd power, or squaring them, you should get -16i. Okay, oops, I skipped ahead of number 3 here. Number 3, I got to go up 1 to get to number 3. Number 3, very similar. 64 would be, or actually this would be -6, this is 64i. So remember, I is straight up. So we're talking about an angle of pi over 2. So it's 64 cosine pi over 2 plus I sine of pi over 2. And then we take that to the 1/3 power, so it's 1/3 times pi over 2, and you get pi over 6. Then you add 2 pi to pi over 2, you get 5 pi over 2, multiply that by 1/3, and you get 5 pi over 6. And then the third one you add pi over 4, so you're saying 1/3 times 9 pi over 2, the pi over 2 plus 4 pi, and you get 4 times cosine of 3 pi over 2 plus I sine of 3 pi over 2. And when you plot those, you have one angle at pi over 6 at 5 pi over 6, and then one straight down for 3 pi over 2. They're all 2 pi over 3 apart, or 120 degrees apart. And this shows how to simplify them. This time you're using a 30, 60, 90 degree triangle to figure out what cosine of 5 pi over 6 or cosine of pi over 6 and sine of pi over 6 equal. Now let's look at the second page. This one's a little different than the other ones. Kind of scrolled up just a little bit. Here we actually need to find r and theta using our formula. R is equal to the square root of 3 squared plus 4 squared. Or you might just recognize it as being a 3, 4, 5 triangle. If you actually drew the 3 and the 4, 1, 2, 3, 1, 2, 3, 4, this is what we're looking at. This is 3, this is 4, and this is 5. And when you do inverse tangent of 4/3, then you get the 0.927295, which is almost 1 radian. That looks pretty reasonable for that. And so I just wrote that as 5 cosine 0.927 plus I sine 0.927. But in my calculator, I am going to use this unrounded form of the number to do future computations. So I multiply that by 1/2. I raise 5 to the 1/2 power, and I just went ahead and wrote square root of 5. You could have put the decimal form of that, but I thought I'll leave that in exact form because I'm already dealing with these decimals that I have to hang on to for later computations. Then for the second square root, I add 2 pi to 0.927 ... and then I multiply that by 1/2. So when I do 1/2 times all of that, I get 3.6052. If you plot the two roots, 0.4636 and 0.3605, it's actually easier to wait to put it in rectangular form, is what I did. I actually put it in rectangular form first, and then I drew this picture, because when you put it in rectangular form without rounding, it's really pretty nice. Remember, you take square root of 5 times cosine of 0.4636 and then square root of 5 times sine of 0.4636 to get you your A and your B. And it turns out you just get 2 and 1 for those two numbers. So when that is simplified, it's just 2 plus I. And then when you do with the 3.6052, you get -2 minus I. So there's my 2 plus I and my -2 minus I. Notice that they are equally spaced. They're pi radians apart, or 180 degrees apart. And you can check this on the calculator by squaring these numbers, but it's really easy just to multiply them out by hand too and see that you get 3 plus 4i either way. Hopefully that was helpful.